Yug, I think you can start, Yug.
Okay, for the last time, actually, am I audible?
You are. Yes.
Okay. So let's start over again. I mentioned that in the first term, we covered parametric methods. Like they were, we had covered values which summarize the population's characteristics for whatever we tested. It was, we had covered mean, we had covered population, we had also covered variance. So, but there was an underlying assumption when we were computing all of these parameters. It was that there has to be a specific distribution that the data follows. But and when these assumptions are valid, then only we get a efficient interpretation to solve this. But this time, at least in module one, we are going to cover non-parametric methods. And for non-parametric methods, the advantage is that there has to be no assumption about the data. It does not have to follow any particular distribution to get us values and to test our theories. It's basically a distribution-free method. This offers more flexibility and robustness to compute our parametric tests. So, firstly, we are going to start with concept of independence. It is that when the occurring or the non-occurring of one event has no influence on the occurrence or the non-occurrence of the another event, that is when we can say and confirm that the test is independent and the parameters are independent of each other. So we'll start with the sums. Is my screen visible to everyone?
Yes, Yug.
Okay, great. So in this question, we have been given the joint probabilities, which is basically this P of A intersection B. So for 0.02, it's the probability of in A1 intersection B1, and we have been given this for A1 B1, A1 B2, A2 B1, and A2 B2. So our basic test, how we conduct for checking if the events are independent or not, we multiply the probability of all the events. What I mean is when if we want to find out if A1 and B1 are independent, we'll multiply the probability of A1 with the probability of B1 completely. So for that, we'll need the row and column totals. I'll be using the sum function just for my advantage, a few of the Excel functions. So firstly, if we have to compute the probability for B1, we'll add all the row total, which is 0.02 in case of when B1 is happening with A1 and 0.15 when the event B1 is happening with the event B2. Same thing we'll do for B2 as well, and we get the total of B1 and B2 respectively. Now again, we'll do this for A1 when we add all the probabilities for A1 when it occurs with the event B1 and with the event B2. Again, we do this for A2 and we get a probability values for the event A2, A1, B1, and B2. Now, again, everyone should know this by now. It's very basic that the summation of all the probability should be equal to 1. So, the summation of events for B category, which is B1 and B2, should be 1. Same thing goes for A. So A1 plus A2's probability should be equal to 1, which is there in our case. Now we'll start with our test of independence. So firstly, we'll compare P of A1. We'll multiply P of A1 with B1. We'll do this for all the values of A1 with all the values of B, all the values of A2 with the values of B1 and B2, so that B1 also gets covered with A1 and A2 alternatively, and same thing goes for B2. This is what I mean so far. So for that, if here we are going to multiply the entire value for A1 with B1. So the value of A1, which is 0.8 for the entire event, remember. And then we multiply it with the value of B2. Right now, let's be concerned about what if our multiplication is right or wrong. Then we come to if it's equal or not, and whether it's independent or not. Then we again multiply the value of A1 with the remaining event of B, which is B2. Now, then we start with A2. Again, we multiply it with B1. And then again, A2 gets multiplied with the value of B2. So if you see, we covered all both the probabilities for A1 with B1 and B2, both the probabilities for A2 with B1 and B2. We even covered values for B1 with A1 and A2, and same thing for B2. But these again, these are supposed to be the intersection values. Just so these are supposed to be the intersection values for A and B. And here we already have the values, which is for A1 and B1, the intersection value is 0.2, which is given to us. Then for A1, B2, the value is given to us. Same for A2, B1, and A2 intersection B2, the value has been given to us. Now, none of these values are equal to the given joint probability distribution table. So,
Excuse me, Yug.
yeah,
Yeah, like there is a suggestion that you do all the calculation without using Excel. Um, I think like instead of solving this using Excel, you just write the numbers without a equal sign, so they'll get an idea, right? What's happening?
okay,
And if you can, you just search TCS calculator on Google, and you will get the exact same calculator we'll be getting for the exam. So they also they will also have a good idea about that.
okay. If anyone's stuck anywhere, let me know. Otherwise, I'll continue. We are towards the end of the song.
One question, which is for the first column, you wrote the first as capital P and the second as small p. Is there a particular reason why?
No, no, it doesn't matter.
It doesn't
It's
matter.
yeah. Okay, coming back. So none of these values they match with the joint probability table that we are being given. Like for P of A intersection B1, we have been what we calculated by multiplying the column and row total for A1 and B1. We got zero point 0.8 after being multiplied with 0.35. We got the value of 0.28. But in our table, it has been given as zero point 0.2. So, and it's not the case for just one, it's the case for each and every uh, event there is. Hence, we can conclude that the events are not independent. And I'll solve manually next time. Other if the uh, calculations aren't tough, I'll do it manually. Till now, does anyone have any problem? Suppose not, we move forward. So
So even if one of them are equal, then it is dependent.
no, no, all of them have to be equal for it to be independent.
Okay.
On okay, now we are moving on to chi-square. Let me just give you all a brief about it, then we can start with it. So chi-square test, we perform a chi-square test when we have two sets of variables within which whose relationship we have to determine if they are independent of each other or not. Again, we do not need any assumption about the data, and it does not get affected when there are any outliers in the data. That's why we use a chi-square test.
You are you saying something?
Uh, did you hear the brief about chi-square?
Yeah, I couldn't hear anything after that.
No, no, after that I took a pause. So y'all can take a minute or two to read the question, and it's the same table in the question that I've put in the Excel sheet, and then we'll start.
Yog, one question.
Yeah,
In the chi-square test of independence, in the concept test of independence, in the practice problem which was given to us after module one, there was this question which had the TV cast of Friends with total lines and funny percentage.
yeah.
Um, so in that question, is the total lines like supposed to be useless compared, and are we just supposed to take the funny percentage into account, or if we can just do that question once after chi-square or before chi-square, whatever.
Actually, in I think the SME live session with the subject matter expert, the sir had solved that question for us.
Okay, all
So
right.
you can refer to that. If you have any problem after that, then I'll be happy to help you.
Okay, all right. Thanks. Yeah.
Okay, so I think you all must have read it by now. And uh, since there was no alpha value mentioned, I have taken it under the assumption that it's zero point 0.5, 0.05, sorry, because that's very normal and very much common practice to take alpha as 0.05. So what we had been given is the observed value between the gender of the customer and the type of mobile connection plan that they have. So the total number of males who would have taken a prepaid plan is 90. Total number of females who would have taken a prepaid plan is 60. And by that, we get the total. After that, adding it to the number of males who have taken postpaid plan, we get the total of the number of males who would have enrolled within the company for the for any mobile connection. Same we get for female, and we also get the total for the customers within a plan. So for prepaid, we have 150 customers, and for postpaid, we have 120 customers again. So now we make a table so that it's easier for us to get the expected values. So for main prepaid, the formula has been given here. I've put the formula already in the sheet. We multiply the column total with the row total. So here in our rows, the total number of males are represented, and in the column, it's the type of plan and the customers involved in it are represented. So we'll multiply 200 with 150 and we'll divide it by 300 to get the expected customers with this criteria of ours. So ideally, it should have been 100. Our expected values for this criteria should have been 100, but it's 90. We do not need to worry right now what it represents. We are just concerned about what the expected value should be. So mail and postpaid, it should have again been 200 into 150 divided by 300. That would have again given us 100. Now, if we had to calculate the same for the other gender for females, we would multiply 100 with the total number of prepaid plans customers, which would have been 150 divided by 300. That would have given us 50. And again, female for the postpaid plans, it would be the exact same calculation again. 100 to 150 divided by 3 again, giving us the value 50. With me so far, everyone.
Yes, yes, yeah.
So again, we calculate the sum of all the same criteria for what we did in the first case. In the observe, the case where we had the observed gender values and type of mobile connection values. The values we get are exactly the same. After that, we calculate the chi-square statistic for each and every case. So we divide the observed minus the expected and we square it. Now we square it because we want it in an ideal range where we can have positive comparable values. Hence, we square it and divide it by the expected. So if we had to calculate the chi-square statistic for male prepaid, we had observed that we had 90 customers. So 90. We subtracted from our expected value, 100 in our case. Then as per the formula, we square it and divide it by, again, our expected frequency is 100. So that should give us a test statistic of 1. Because this is 10 squared by 100, which gives us 1. Because 10 squared is 100. I think that much we can figure out that now. Then again, we do it with male and the number of postpaid male customers. So we had observed that we had 110 people, 110 males rather, and we had expected only 100 of such customers to be there. But then again, we square it and divide it by our expected frequency of 100. If you observe the difference is 10 again, and see, and the denominator is also the same. So we'll get the value 1 again. Moving on to the females chi-square test statistic. For females in the prepaid plan, we had expected 60, we had observed that we had 60 such customers, whereas our expectations were only 50. Hence, we'll subtract 50 from the 60, square it, and this time we'll divide it by the expected female customers for the prepaid plan, which is 50. So here we get again 10 squared in the numerator, but we'll divide it by 50. So we divide 100 by 50, hence we get the value of 2. Now we do the same thing, just a mobile connection plan changes. It's now postpaid. So we subtract 40, and we had for the same plan we had expected 50 such customers. So we again square it and divide it by 50. If you observe, just like in the maze case, the second case, the second chi-square test statistic, the difference is the same, and we again divided by the same denominator, giving us the value 2 in our case as well. So for mail prepaid, our chi-square test statistic is 1. Same as for postpaid. For females, it's 2 for prepaid plan, and it's the same for postpaid plan. Now here we sum the values of total test statistic we got for the prepaid plan. We'll do the same for postpaid plan. We'll do the same for our expected number of males who would be having the plan and the chi-square test statistic for that plan. 2 for males, 4 for females. And 3 plus 3 would give us 6 for prepaid and postpaid plans, 2 plus 4 for the genders. All of them would give us the value of 6. So our chi-square test statistic has come out to be 6. And what do we do now? So for this, firstly, we'll calculate the degrees of freedom. Degrees of freedom. In such a case, we had 2 observations for the types of mobile connection and 2 with the gender. You could also say there were 2 columns and 2 rows to make it easier for calculation, because the formula is r minus 1 multiplied by c minus 1. Hence, you could say it's r minus 1 into c minus 1, but that would not be a good practice, because a sum later would tell us it's not that necessary to remember it by rows or columns. So in our case, in R, there were 2 parameters. For C also, we had 2 parameters. Our degree of freedom would be 2 minus 1 multiplied by 2 minus 1 again, giving us the total degrees of freedom as 1. Now, let's not forget we had a chi-square test statistic as 6, our degrees of freedom as 1, and our alpha value as 0.05. How do we compare and how do we get to know? Yeah.
Can you explain the degrees of freedom again?
Yeah. See, firstly, we have a formula directly for it. Degrees of freedom. There are 3 formulas for degrees of freedom. In this case, we use r minus 1 into c minus 1. Why? Because none of our parameters like the gender or the mobile connection plan, none of them are continuous. We do not have a range for any of those. Like we do not have the range for the customers as between 0 to 10, between 20 to 30. Hence, we do not use the other formula. It's just you could remember it by rows minus 1 into columns minus 1 when there are no intervals given, and when there are 2 parameters like the type of mobile connection plan and the gender of customer.
Okay. But then what is row minus 1 and column minus 1 here?
We subtract 1 so that our as I had mentioned earlier, it's chi-square is a little more robust as a test because it here only it gives us less degrees of freedom to be wrong of sorts, I would say. That's how I put it. That's why it gives us more robustness. So
Achha,
there is less margin of error, something like that. So we calculated that we got degrees of freedom as 1.
okay, so if it was continuous, then we would have used a different formula.
Yes, I'll explain that. Don't worry.
Achha, theek hai, theek hai.
So alpha in the starting we had mentioned it would be 0.05. We just calculated the degrees of freedom. Now there is a test statistic attached with this as well. Rather, there's a critical value for which our alpha would be 0.5, our level of significance or alpha, whatever you may call it. You should just know that both of these are there. They might use them interchangeably in the exam to confuse us. Hence, alpha or level of significance 0.05, degrees of freedom 1. To calculate the critical value for this, we'll go to the chi-square table, chi-square distribution table. Here, the degrees of freedom are given as the first column. If you see, it starts from 1 till here, it's given for 29 in the sheet. And these are our alpha values, which we consider. So here it has been given for 1 degrees of freedom and for our 5% level of significance or zero point 0.5 alpha, it's 3.841. So we go back 3.841. We get that as a critical value. Now there's something you all always need to keep in mind for rejecting the null and the alternate hypothesis. And I realize we haven't stated our null and alternate hypothesis. Zero H alpha. My apologies. So for this, we were testing if there is any relationship between the customer, the gender of the customer, and the type of mobile connection. So in a chi-square test of independence, a null hypothesis always will be that there is no relationship. There is no relationship or our values. Suppose in this case, it's between gender of customer and mobile connection plan. So our null hypothesis will always say that there is no relationship between any of our parameters. And it would be the exact opposite case for our alternate hypothesis that there must be some sort of connection between these values. So let me highlight it. In our null hypothesis, there is no relationship, but in our alternate hypothesis, there is a relationship between our parameters. Now, after we get the critical value, and our chi-square test statistic, we need to find out
I
how
have
we
a
will.
doubt.
Yeah,
So we took alpha value as 0.5, and when
yeah.
we were finding the critical value, we took the decimal value as 0.05. Why is that?
Uh, these are our alpha values only, 0.05.
So, but our alpha value was 0.5, right?
No, no, it's 0.05.
Uh, okay, okay.
So, yes, coming back, when and when not to reject the null hypothesis. So, for a chi-square goodness of fit test, or rather any chi-square test, you can reject the null hypothesis when your test statistic is lower than the critical value or your p-value is less than the alpha value. Here, we would get a p-value by using a Excel function, which I know would it's not feasible for us, and it would not be given to us to solve in Excel in our final exams. It's I'll show it to you once, but remember at least this in mind and this in mind because they might as well give us the p-value itself and they will give us the alpha if the case may be in the exam. So we have to be prepared for anything. So if our test statistic is less than the critical value, we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. So here, a test statistic of 6 it's greater than our critical value of 3.841. So as per this table and what we had learned so far, if our test statistic is more than the critical value, we would I wouldn't say accept, but in the exam they could use terms like less evident to like go against the null hypothesis, something like that, or fail to reject or accept the null hypothesis. Any of these terms could be used. Hence, here we fail to reject the null hypothesis, which is so if we reject the null hypothesis, which is there is no relationship between the gender of customer and mobile connection plan.
You. So whenever alpha value is not given, we assume it to be 0.05 exact.
See, I'm not the right person to ask because I'm neither a subject matter expert or a faculty. But in all of the sums we had solved earlier as well, we had been given an alpha value.
Huh.
And if I say that, oh, you can just assume at 0.05, and if a case there is a question in the exam where you have been given the p value and you use this method to calculate via test statistic to accept or reject the null hypothesis. And if you get it wrong, the burden lies on me. And because I taught you wrong as well. So I can't say that alpha should be 0.0.5 if nothing is given.
Then what do we take if alpha is not given?
Honestly, even I don't know the answer of that because even I haven't been able to find that out. Because ideally
So
it
Uh,
should be given.
Okay, so like you just assumed it to be 0.5 just to explain us this sum.
Yeah. So
No, I'll just take that question. Look. So throughout the modules, professor mentioned p-value we consider as 0.05. So if it's not mentioned, you consider it as 0.05 itself.
Okay, so if nothing is given, we just go with 0.05.
Yeah, throughout the module, professor discussed the questions based on the p-value as 0.05 itself. So no issues, no issues. You can.
Okay, thank you.
okay. So since our test statistic was greater than the critical value, there might sorry, there might not be a relationship between our parameters. Does anyone have a doubt so far?
Uh, yes, I want. Am I audible?
Yes.
I wanted to ask, can you explain how you got the critical value again? It's
Yeah.
based on alpha, I know that much, but the table, can you show that again?
Yeah. So again, keep this in mind. Our alpha is 0.05. Our degree of freedom is 1. In the chi-square distribution table, the very first column is the degrees of freedom. That what we calculate. So in our case, it's 1. So for that row, for the rows with all the degrees of freedom 1 at different alpha levels, we look for the one which is under our alpha value. So in our case, our alpha was 0.05 and the degrees of freedom was 3.84. So that is how we get the critical value.
And the degrees of freedom is the number of row variables minus 1 into the number of column variables minus 1, right?
Yes.
All right, thank you.
I have a question regarding defining the hypothesis. Am I audible?
Yes.
So the H naught is always supposed to be a negative statement or the one given in the question?
So the one given in the question, it won't necessarily be a negative question, or they might even write like it like this. Uh, so type of so type of mobile connection plan is independent of the gender. So if you see, this is in no way negative. The null hypothesis, it should just display that there is no dependence in either of the parameters.
But here in the question, it written whether we have to find whether there is any relationship or not, and you've assumed that there isn't. So can't we assume that there is, and then the alternative would be that there is not?
See what we are trying to prove, not prove, rather what's in our given statement. Firstly, chi-square is a test for independence itself. Hence, that that is the first reason. And because we are conducting a test of independence, automatically what we are trying to prove, not really, because our chi-square is a test of independence, our null hypothesis is set to that there is no dependence in any of the parameters.
Okay, yes, that makes sense. I missed that. Thank you.
Yog,
Yes.
can I just conclude this and can we move to the next session? The goodness of it is.
Yeah. So guys, I had mentioned that there was another formula to calculate degrees of freedom.
You
Yeah.
before that you just conclude. I mean the can I conclude that independence test?
Rishabh, your voice isn't clear.
Yes, it is breaking.
Once
Yes, we'll ask you out.
Hi, can you please drag down to the table where you have written reject the null hypothesis and do not reject the null hypothesis?
Yes.
Okay, so as far as I know, in chi-square test and both goodness of fit and chi-square test of independence, when the test statistics value is less than the critical value, we like fail to reject the null hypothesis. And when the test statistic value is greater than the critical value, we reject the null hypothesis. That is correct, no?
Wait, now I'm back.
I
What
think
did
you
you
have.
say?
I think that you have written opposite things. I'm saying that.
Oh, maybe.
Just check it
Because,
out.
yeah, I was before the session, a question did mess it up for me.
I'm sorry, I'm not able to hear you properly, Yog.
Okay, yes, you're right. I'm so sorry, guys. A very serious error from my end.
Thanks a lot. I was thinking that I'm studying wrong from the past few days. Thanks a lot.
No, no. It's because even I'm getting confused because of a few sums.
So our answer changes now.
Yeah. So,
Okay.
Actually, could you find out what Rishabh was trying to say?
Yes,
no,
I will tell him that. Yeah, so it is like same like the previous thing.
Guys, we will be sending you this sheet, and there are two questions for you about chi-square test only. And it's only the only thing that differs is how you calculate the degrees of freedom. So for this case, our degrees of freedom would be the interval categories -1. So here are intervals or categories. It it basically signifies the average monthly bill amount. Return it as intervals because it's really easy to understand right now. Like if it's less than 250, if it's between 250 and 500, if it's greater between 750 and 1000, if it's greater than 1000. So those are your categories. You subtract one and then you subtract the parameters estimated. So for the intervals, the parameters estimated in the customers for Kochi, for the other place. It's like that. So for Kochi and Thiruvananthapuram, this is the only difference in any chi-square test statistic, in any chi-square test rather, the degrees of freedom. In the first phase, it's really easy. Here, but degrees of freedom would be R minus 1. Because here your R has two parameters. Your first parameter is that the associate has a doctorate. Second, associate he doesn't have a doctorate. Hence, you should just be mindful of such parameters and such tests because you have been given use a relevant chi-square test and decide if 10% of associates have a doctorate. So here your six, and it was found out that 6 associates had a doctorate. That would be your first observed value. And the remaining out of the 50 of the sample associates that have been taken into account, the rest of the people would have been the second observed category, which is O2 for this, the associates who don't have a degree. And 10% basically gives you the probability of associates having a doctorate within the sample. So your expected would be 5, which is 10% as mentioned here. And 90% of these associates taken into consideration, they would not have. So the expected for the second parameter would have been 45. That's the only difference that is there in the chi-square tests.
Okay. So there are three ways to calculate degree of freedom.
Yes,
So one is where the columns and the rows are given. One is
yes,
where only the row is given, and the another one is where they are like in continuous.
yes.
Okay. Then what? Okay.
Sorry.
No, understood, understood.
Could you just solve the difference of freedom for this question?
Okay. So your the interval uh, categories, they have been given as 1, 2, 3, 4, and 5, starting from less than 250, ending at more than 1000. So you have been given 5 intervals or 5 categories. They have been estimated. So they have been estimated for 2 parameters. If there's something wrong with the name, please let it slide this time. So first, you start with the intervals, the total number of intervals that were there. You subtract 1, and then you subtract for how many parameters they were estimated. So these are for 2 places. If there had also been for another place like Mumbai, another for Bangalore, another for Delhi, like obviously keeping in mind the intervals or categories, the degrees of freedom can never be 0. Keep that in mind. So if anywhere it's 0, either your degrees of freedom is wrong or you should use another test and not chi-square. So here you would get 2 as the degrees of freedom. And in the first case, TOF would be 2 minus 1 is 1.
Dhruv, when we will know that we need to use chi-square test of independence and when we will know that we need to use chi-square test of goodness of fit test? Because in both the DO, like the degree of freedom method is different, no? So how will we know that which one to use when?
No,
You
see, yeah,
you can I just share my screen once?
Kashyap, your voice is
Is it fine?
still cracking.
Can I share my screen once?
Rishabh, can you put it in the chat box? I'll read it. Okay,
Can you
sorry, what was your doubt?
my doubt was that in chi-square test of independence and in chi-square goodness of fit test, the methods of calculating degree of freedom are different, no? So when we'll know that we need to use which one, will they specifically mention that we need to use goodness of fit test or we need to conduct the test of independence?
See, for the methods aren't different for goodness of fit test and test of independence. The methods are just the same, only your hypothesis changes. So if it's a goodness of fit test, the question would be like, does the distribution or does the data follow like uniform distribution, Poisson distribution, something like that? And if uh, and for test of independence, on your hypothesis would be that null hypothesis would be that they are independent, the parameters are independent of each other, and they are not independent of each other, would be your alternate hypothesis. That's the only thing.
Okay. And the chi-square test of independence degree of freedom is calculated by r minus 1 into c minus 1, right?
See, for both of them, it's again degrees of freedom. Calculation is also the same on depending upon the table. So for the question in slide number 2, if you would have seen, it had just two parameters. So we did r minus 1. For another, there was a table and it was two column variables, two row variables. Hence, we did r minus 1 into c minus 1. For third, there were intervals and parameters estimated. So we subtracted that and 1 from it.
Can we get the formula sheet or something that will be much more easier?
Yeah, I think it had been shared, but I'll make sure it's shared.
Cool, thanks.
So how did you get the p-value for the sum that we solved? The chi-square statistic was 3 point something, and then how did you get the p-value? What
We did
formula
not
did you?
we did not calculate the p-value actually, because the p-value calculation for us as students in an examination center, it would be via Excel functions if we are given. But since we wouldn't have the liberty of using this, but since we wouldn't have the liberty to use Excel in the examination center, I hadn't calculated the p-value. If you want, I'll I'll later show you if the p-value is given and what we calculate and what we find out, what should be the case in that, the answer in that case, sorry, what should be our answer in that case if the p-value is given. Otherwise, we shouldn't be dependent on p-value.
So how? So the p-value was given in the question. Will be given in the question. Or
Not
do we not need?
necessarily.
Do we not need the p-value at all?
No. See, for chi-square test, you can either solve it, like get the final answer of accepting, rejecting the null hypothesis by either p-value or the test statistic. By either of those.
So we only need one of those things. Okay.
Yes.
Okay. All right.
Also, what about the Wilcoxon?
I mean, yeah, I had it in the sheet to be solved, but show us
You am
something
I
that's
audible now?
yes, Rishabh, your voice is better now.
I'm audible, right?
Yes, you are audible.
No, I'll
But it's
share
lagging a lot.
screen.
Yuk?
Yes,
Yeah.
sir, you would share the screen.
My screen is visible, right?
Yes, it is visible.
So till now you discussed two main topics. So in total we have three main topics in module one: chi-square test for independence, goodness of fit test for distribution, and thirdly Wilcoxon signed rank test. Chi-square test for independence. We take null hypothesis as in total we have 6 steps.
Your voice is
First,
breaking again.
is it audible now? Hello.
No.
Rishabh, you might share your PPT or Excel with Harshit or Yug. Ask them to share it, and you directly speak, bro. That would be better.
You continue with your module.
Okay. Uh, just to make sure, can everyone see the screen?
Yeah, it's
Yes.
visible.
Yes.
Okay, so we'll solve Wilcoxon test first. Then, if time permits, I'll continue with chi-square. So the question has been given to us using relevant tests. Find out if the scores deviate from the median score of 150. And we have been given that our sample size is 10 and a critical value for that sample size is 8. Our approach to this, firstly, how would we identify that the given the question has to be solved via Wilcoxon signed rank test? Here we have been given median score of 150. Okay, so if median is given, it's a no-brainer. We should go for a Wilcoxon signed rank test. And it also mentions deviation from a particular value as well. Here, ideally, it should be median because that is what has been taught that for Wilcoxon signed rank test, we calculate how much there is deviation from the median of any value of x. So here it has been given as 150. So our approach, firstly, we should lay out the null and alternate hypothesis before I forget it again. So here our question is if there is a deviation. So that would automatically be our null hypothesis because Wilcoxon signed rank test, it it is basically done for testing mediation. So the score is from the median of 150 and the opposite of it would be our alternate hypothesis. So firstly, we laid out the hypothesis for our test. I'll remind once again what we are testing mediation with Wilcoxon signed rank test. That's why our null hypothesis is that it mediates. Our approach towards this is first we find the difference between the runs and the median score of 150. So firstly we subtract 150 from the first value 120. That would give us 30. So in the next case 20, 50, in the next case 25, sorry, minus 25, and then minus 10. We continue with this till whenever our sum ends, because it's just me right now solving it with less than 30 frequencies or less than 30 sample size.
In the first one, it should be minus 30 then, right? Considering we are
Yes,
doing 120 minus 150.
my bad. Then we consider the absolute value of these differences. So for the first, we had gotten a difference of minus 30. But since we are considering the absolute values, we do just 30. Then 50 remains as it is. Then we do start with 25. Minus 25 times positive. Minus 10 the turn.
You have written the hypothesis, like the null hypothesis will be the alternate and the alternate will be the null, I think. Because the professor taught us that the median will be equal to that it accepts it, and the null will be the opposite of it. No? Like the median will be equal to 150, and in the alternate hypothesis, it will be median is not equal to 150. And I think you have written opposite. I'm not sure
Yeah.
if I'm wrong. Please correct me.
Rishabh or Harshit, can you check? Okay, we'll focus on our hypothesis later. I think everyone's more focused with how you do the steps. So after considering the absolute value of the differences, we will rank these values. So there are basically two ways of ranking. It can either be ascending or descending. We start with ascending because there is a concept that needs to be explained. For the first rank, we will obviously choose the smallest value that is there. But in this case, if you see, there are two values, two equal values for the first rank, which is 10. So
Sorry
for
to
rank,
cut you here. Ninth one is actually 30 and not 20. The answer will be wrong. That's fine.
sorry,
The ninth one, it's 30. The difference is 30. 30.
oh yeah, thank you for that. So coming back for the first rank and for the second rank, we have equal values, just 10. Ideally, if there are equal values, the ranking should be equal, because otherwise if we give them the best rank or the worst rank or just however our mind may please. Because if you give one here to the one which corresponds to the negative difference and second to the one which is positive, it will lead to certain improper test statistic calculation, which would come to bite you later in the solving. Hence, we take the average of the ranks. Differences. We take the average of the ranks for the equal values. So for both the tens, we get the rank as 1.5. Now the ranks both 1 and 2 now stand exhausted. We can't use either of those again because whatever we have allocated as the rank is the average of both of those ranks. We have 20 next, which would take the value, which would take the rank as 3. Then again for fourth,
I'm sorry to. You guys saying something because I am not able to hear you.
Yug, you are not audible.
Hello.
Yes, you are now audible.
Okay, great. So again for 30, we have the fifth and sixth rank tied. Hence, we would again give them the average rank and exhaust both of these ranks, fifth and sixth. Okay, 4, 4, 5, 6, 7. Okay, sorry. Coming back, we have for 3 ranks, we have 3 equal values. So we would give them the average of those ranks and we would exhaust all of those ranks. So there were 330s in our case, and for the rank 5th, 6th, and 7th. Average of the ranks 5, 6, and 7 is 6. Hence, we give them the rank 6 and we exhaust 5th, 6th, and 7th, all of these 3 ranks. Next, we have 40, which would get the 8th rank, 50 getting the 9th, and 60 with 10. Then we bring back the sign that was there in the original difference in our first step, which was this one. So for the first value, we add a negative sign because the difference was negative. Then we add a positive rank, positive sign, sorry. Next two were negative and all of the next values, they were positive. After that, we calculate the value of all the positive and the negative signed ranks. So for all the positive values, which were 9, then we had 8, then 3, then 6, then 1.5, then 6 again, and then 10. we'll consider the positive and the negative signed values for all the ranks individually. So W plus is the sign of the positive difference ranks, and W negative is the total of the ranks for all of those differences which were negative. So here we had 6, 4, and 1.5. So for W positive, which I'll repeat, it's the sum of all the positive signed ranks, or sum of all the ranks whose difference, the first step, our initial difference was positive. And that comes out to be 43.5. If I'm wrong, please correct me. All help is welcome. And for the negative signed ranks, a summation of all of the negative signed ranks, it's 11.5. So our test statistic is actually W. And we had two values, W plus and W minus. So W is the smaller of those values. So from 43.5 and 11.5, the smaller value was 11.5, and we consider that. So this is W is our test statistic. And coming back, focus on this one. When do we reject and not reject the critical values? Our hypothesis, sorry, our null hypothesis based on the critical values. So in this case, our solved W is greater, or our test statistic is greater than the W critical value. We were already given the critical value, which was 8, but in case the need ever may be, when our n is less than 30, we have to basically look at a table to get the critical value. The first column again is the n, our total sample size. In this case, our total sample size was 10, and the value corresponding to it was 8. So 8 is our critical value as written below table 10, critical values for the Wilcoxon signed rank sum test. So a critical value is, yes.
In the table, can you explain what is there in the table? It's very confusing to understand. TU, TL, what are those? TL, TU, yeah.
Yes, it's
Lower and upper.
confusing for me as well. But
Gotcha.
based on what the professor taught, we look at the value immediately corresponding to our sample size. So for our sample size 10, we had considered the value as 8. So 8 becomes our critical value.
Okay.
So yeah, our critical value is
Acha,
8.
one more thing. Just to confirm, for both the cases, the test value should be more than the critical value, right? According to that chart, because I think you wrote it wrong there initially. Huh. So इसमें for both the cases, the test statistic should be more than the critical value.
I think Sir had mentioned that it's opposite for the cases, right? So like for Wilcoxon, it should be more. For chi-square, it should be less.
मतलब
मतलब अगर हमें रिजेक्ट करना है, अगर
हाँ
हमें नल हाइपोथेसिस रिजेक्ट करना है, तो chi square में हमारा टेस्ट स्टैटिस्टिक क्रिटिकल वैल्यू से ज्यादा होना चाहिए एंड विल्कॉक्सन साइंड रैंक टेस्ट में हमारा टेस्ट स्टैटिस्टिक W वो क्रिटिकल वैल्यू से कम होना चाहिए.
Yeah, but when we were solving the first sum, वहाँ पे didn't you say that the thing that you wrote here was wrong?
Yeah, but I corrected it. When it was mentioned, I corrected it on the spot. And but any which ways, even if I have confused any of y'all, I apologize if I have. It's always opposite for both of these cases.
Okay, okay.
Yes.
Thank you.
So
Yog,
welcome. Yeah.
we will be provided with this table in the exam.
Which one? This one? I don't think so.
No, not this
Probably
one.
not.
The values.
This one?
Yes.
Yeah, hopefully it is.
Currently,
Because
they are not announced anything. We have to wait for
They
their.
are still thinking about it, and this is not the table we'll be provided with. We'll be provided with the table which is similar to chi-square one, in which there is significance level, because this is much more confusing. There is another table of like the Wilcoxon T table only, in which we can find the value, and in that we have significance level value in like 0.055% significance level, and then we can just do it like the number, like he told how to check it, and in that it is much more easier.
Okay, so we from there we have to see the sample size value and the significance level value, and then we can take
Yeah,
that.
like significance value will always be equal to 0.05 only in most of the cases, right? They have told us
Yes.
it's 5% significance value, right? So how we see in chi-square, like we see the degree of freedom and the significance value, and we match the value. Same in that we have to see the n value and the significance value at 0.05. I can tell you, like if you want me to tell
Okay,
you
okay.
any,
No, I got it. Instead
yeah.
of degree of freedom, we are having n value here.
Yeah, exactly. Like for n number of people, n is equals to 10 and significance value is 0.05, then the critical value will be 8 according to that table.
Okay. Thank you.
Welcome.
okay, so coming back, our W, it's less than W critical, which is, sorry. So our value of 11.5, the even after considering the smallest value we have, a smaller of the values we have, 11.5, it's greater than a critical value of 8. Hence, we fail to reject the null hypothesis, which is we kind basically meaning we kind of accept that the score, it has some sort of mediation from the median score of 150.
Can you
And that,
explain?
yeah,
Can you explain why we took 11.5, like the whole W positive and W negative? Can you explain that part again?
okay. So W positive, it's the summation of all the ranks for which we had the difference positive. Hello.
Yes, I got that, but like, why are we choosing 11.5?
Uh, that's a good question. If I have written it somewhere. Uh,
No, you said that you have to go for the smaller value, right? So out of both
Yeah,
of
I
them,
can
the
answer
smaller
that.
value is.
Yeah, according to the rule, it says that whichever is the minimum value, we take that. Like if W plus was minimum, we would have taken W plus, but in most of the cases, W minus is the minimum one. Like the according to the sample paper and the questions in the midterm.
I'm having a doubt. If we assigned the values in the descending order, then also we would have taken the smaller value only.
Yes.
Okay.
Yeah, so this puts an end to module 1. If anyone has any doubt in any question, otherwise we'll take 5 and Rishabh will start with module 2.
Can you show that chart again?
So, you will
The
you share these tables with us, charts with us?
Yes, Rajit, we will upload the Excel sheet on the drive link that we have already provided to you.
Okay, thanks.
Yeah.
I'll
When do we
verify
have to
this for,
use?
sorry.
When do we have to use Wilcoxon signed rank test and rank sum test? Like,
You can I take that?
Yeah, sure.
My screen is visible, right?
Yes, it is.
So we have discussed three major topics. In module 1, we have three major topics. Name of the module is non-parametric test. Basically, we shouldn't use any mean, mode, median, but we have to find the results. Okay. So we discussed three major concepts: chi-square test for independence, goodness of fit test for distribution, and Wilcoxon signed rank test. For we used this chi-square test to check whether the data is independent or not. So we have 6 stages or 6 steps. First, we write the hypothesis. So the null hypothesis is it is independent. Alternative, it is not independent. Secondly, we find the expected frequency from the table. So there will be a table given. The given table is the observed frequency. We find the expected frequency. So the equation for the expected frequency is marginal row total into marginal column total divided by overall sample size total. So after this, we'll be getting a new table. So we currently have two tables. One is the observed frequency. Second is the expected frequency. In step 3, what we do is that we take each value, observed value minus expected value whole square divided by expected value. We use this equation and we sum up the whole values. Fine. In step 4, from here we'll be getting a value, right? Let's assume we get XYZ. So using this XYZ and degrees of freedom in for finding chi-square test for independences, number of rows minus 1 into number of columns minus 1. So we'll be getting a value here also. ABC. So using this XYZ and ABC, we find the chi-square value. This chi-square value will be compared with the given p-value. If p-value is not given, you should take it as 0.05. If it is given, compare the chi-square value with the given p-value. In conclusion, with respect to the value, we compare those and we conclude that either null hypothesis is rejected or we fail to reject the null hypothesis. Fine. For goodness of fit test, it is majorly used for finding the distribution. So let's assume there is a data and it is mentioned that it is a normally distributed data. So we have to find whether it is actually normally distributed. Fine. So same process, exactly same process as the chi-square test of independence, just one difference, that is degrees of freedom. So there will be a number of intervals minus 1 minus number of parameters. What is this parameters? For normal distribution, we need mean and standard deviation to find the normal distribution, right? So there are two parameters. So let's assume there are like 5 number of intervals, 5 minus 1 number of parameters to find normal distribution or whether the data is normally distributed, 2 mean and standard deviation. So we get the data as answer is 2. So for this, the degrees of freedom is 2. Same step again, find the chi-square value using the degrees
Can
of
you
freedom.
repeat that, please, last part?
This one? Which one?
The degree of freedom of fitness test.
Fine. Let's assume 0, 2. So let's assume this is the observed data given for you. There are 3 intervals, right? So number of intervals will be 3 minus 1. 1 is part of the equation, minus 1. Number of parameters. The number of parameters will be dependent to which distribution it is mentioned in the question. So let's assume it is mentioned, find whether it is normally distributed using the goodness of fit test. So we already know it is a normally distributed data. So what are the 2 main parameters we require to find a normal distribution? Those are mean and standard deviation. So 2 parameters. So we already wrote 3 intervals minus 1 from the equation minus number of parameters. Since it is normally distributed data, we have 2 parameters, 2, and we get 0. This shouldn't be the case. Let's assume.
Right, all right.
Let's assume 4. Our degrees of freedom is 1. Using the value from the here let's assume xyz. Using this xyz and 1, we find the chi-square value. Then again, we compare it with the p-value. If p-value is not given, it's 0.05. If p-value is given, you can take that particular p-value for the comparison. Then we'll write the conclusion that this data is normally distributed or this data is not normally distributed. The hypothesis will be different here. Thirdly,
The
Wilcoxon.
p value is the level of significance, right?
Correct.
All right.
Third, we've discussed Wilcoxon signed rank test. So all the practical thing I think you have discussed or you have explained. Majorly, Wilcoxon signed rank test is used to compare 2 related samples. So it is an alternative to the t-test, which we learned in the term 1. These are the main 3 parts of non-parametric test. Chi-square test for independence. To find what? Independence. Whether the data is independent or not. To goodness of fit for distribution. To verify whether the given distribution or whether the data is distributed according to what it is mentioned in the question. Thirdly, Wilcoxon signed rank test, comparing 2 related samples. It is an alternative to t-test, which I've studied in the term 1.
Do we
If you
have
guys have any,
Wilcoxon? Do we have Wilcoxon ransom test?
Yes, in exams we do have. There are 2 questions also in the sample paper.
if you guys have any doubts, you can ask you.
Yeah, I just had a quick question. So I think for the goodness of fit test, we used the uniform distribution. Can anyone help me out by understanding how do we figure out whether the distribution is Poisson or uniform or exponential, or will it be mentioned in the question?
The thing is that if there is a data, 1 second. So the question is find whether it is normally distributed. And
let's assume we found like we've applied all these 6 steps and we made a conclusion that it is not normally distributed. So what's next? Basically, for exam, like we are mostly focused on the exam perspective. So for exam, that's the end. Once we give the conclusion, question ends. In real life, if it's not normally distributed, then you next check for the uniform distribution. What changes? Nothing changes except the parametric value. I mean the number of parameters here. I don't know how many parameters are there for uniform distribution. If it's 3, let's assume you make it 3, then you will get another conclusion. Likewise, if you want to check for multiple distribution, if you are not getting a positive conclusion, you will check multiple times for each distribution. Then only one thing which changes is the number of parameters.
Okay, understood. My question was actually a little bit different. I think in the sessions that professor does, there was this question where he found the probabilities of the distribution and then multiplied that with the observed value to get the expected value. So I just wanted to figure out to find the probabilities, which formula should be used. Because if we use Poisson, then the uh, formula will be completely different. But since we're keeping the exam focus, maybe I'll get in touch with Rishabh or you post this session. But thank you.
You want to take this?
Yeah, sure. So if in the question, you should look for keywords for, you mentioned that sir multiplied it with the probabilities and all. That happens only when we are using Poisson distribution. And for that, in the question itself, we have been given the mean or the average. If not, we could also have been given that e raised to minus some value. It corresponds to this value. So whatever, if you get that, if it's given e raised to minus whatever, then it's Poisson distribution. And there is another case where the sample size is very large, but the initial probability given, that is very small. So when you multiply that, you get the average for Poisson distribution itself. So these are the 3 cases in which you could identify you have to use Poisson distribution and then continue with chi-square.
Okay, thank you so much.
Right.
Can you explain once the Wilcoxon ransom test?
Can you come again?
Sorry.
Can you once explain the Wilcoxon ransom test, or you can like tell when do we have to use it?
We use it when we want to find some deviation between 2 sample sizes or when we want to find deviation between some observed frequency and a median observation of that data.
Okay. Like here we have got one sample only, and for that we'll get 2.
Yes.
I think we can conclude, right?
Yeah, module 1 is done.
No, we'll do one thing. We'll take a break for 5 minutes and we'll join after that and we'll start module 2. If you guys have any doubts for module 1, we'll discuss it in the end after the midterm 1 discussion. Fine.
Okay, guys, we will start module 2 at 6:20. Okay, Rohit, and sorry, Rishabh and Yug.
Yeah, cool.
Okay. No. We will continue on this platform only. If anything happen like the like previous thing, we will shift to the another. Guys, anyone know where does the recording will is stored in the MS Team?
It would be stored in your like drive or something, the Microsoft drive.
Okay, not in the internal storage.
What?
Not in the internal storage of the device.
You don't have internal storage?
I was asking, it will store in the internal device or the MS Team.
No, I think it's the Microsoft drive. I guess so.
Okay. In your OneDrive, okay.
Yeah,
Okay.
most probably gets stored in your OneDrive, and then you can shift it to your desktop from there.
Fine, Rohit, thank you.
Let's start, right?
Yes, yes, sir, you will.
Guys, please put a thumbs up or something. So that we can start immediately.
Guys, give up a thumbs up. So we will start.
So once again, I'm concluding module 1. So module 1 is about non-parametric test, how to find things without using the mean, mode, median, standard deviation, etc. We had first concept, chi-square test for independence. So we use that to find whether the data is independent or dependent. Secondly, we discussed chi-square test for goodness of fit test. There, our main objective is to find which distribution type is it. Fine, to confirm whether the specific distribution or a specific distribution follows in the data. Third, we discussed of the Wilcoxon sign rank test, where we compare two dependent or related samples. It is an alternative to t-test. This is all about module 1. Module 2, we have a lot of theory and a few practical, but I think compared to module 1, it's like these are much simple. The equation seems so complex, but calculation is quite simple. So today I'll share my screen now. I've made a PPT kind of thing. So I'll share the screen. We'll discuss each topics. And for the practical part, I'll be using the TCS, that calculator. I'll show you guys. Basically the calculator which we will be getting. So we'll be having an idea how to calculate using the calculator itself. So that's the whole objective. Harshad, is my screen fully visible?
No, there was a pop-up audience window and the full screen mode.
Right.
It is
Let's
visible.
start. Let's start, right? Please give
Yes,
a thumbs up or something. So we'll proceed. Fine. Yes. So module 1 was parametric test. Module 2, we are discussing about advanced regression. Like we have already learned, I've not learned, but in term 1, we already have like linear regression, multiple linear regression. So this is basic. The name is advanced regression, but I think the concept is much simple. We have a lot of theory, and we have a few practicals. That's it. It's simple. Comparatively, it's simple. So let's start. So the main topics we have in this modules are, first is the linear regression. We are like, there is a, I think there are 2 modules or something in term 1 about linear regression. Here, there's a brief explanation of what is linear regression is, the theory and the practical side. Theory and both, it is actually simple. Even if you don't know anything about regression, it's simple. Then we have assumptions of linear regression. This is theory. It is actually 5 points, which are so important because for midterm 1, there were 2 questions. If I'm not wrong, minimum 2 questions were there. The first 2 questions for me were of this, related to these assumptions. And I think for the sample paper, in the sample paper 2, there is a question, I guess. So this is so important. These both are mostly theory. There is a small practical part. The main concept in this module is logistic regression. And we have a theory. We have 2 concepts. These 2 concepts are easy concept. This is a practical one. This is just a theory one. And we have a practical session for logistic regression. This is more kind of a where we have to solve problems, an area where we have to solve problems. And lastly, we have nonlinear regression. That is to a theory. This is our main agenda. So first we'll discuss linear regression, assumptions of linear regression, which will complete, I would say within 15 minutes or so. This here will take a bit more time because there is theory, there is practical, and you should also have a conceptual clarity, right? Last, we have nonlinear regression, which is so simple. Let's start. So let's assume here is a guy. Let's call him Bean itself. So this guy runs a lemonade shop. Fine. This guy sells. This guy runs a lemonade shop. Fine. Easy. He just want to know what are the things affecting his sales. Fine. So let's assume there is a school nearby his shop. Thus, there can be more students who might buy lemonades from him. So he was more kind of he's basically a statist, like he's quite good at statistics. See, he wants some pure data to analyze and interpret how many number of lemonades can I sell if it's a Christmas day, if it's a working day for the school, etc. So he want to analyze all those. So his main objective is what? Know how many lemonades he sells per day. Fine. So there are like multiple factors, right? If it's a sunny day, there can be more sales. If it's a rainy day, that's why I've included these two sides. If it's a rainy day, there can be less sale. If the foot traffic, the number of people walking beside his shop is very high, then the chances they may buy his lemonade is also very high, right? There are n number of factors that can affect the number of lemonades that he sells. So throughout this whole module, just be aware of this guy out here and his lemonade shop. If you have this image in your head, you will get you. I mean, if you forgot something, you will sort it out. So this is the whole case. Mr. Bean runs a lemonade shop. He want to find how many number of lemonades he can sell, whether it's a sunny day, whether it's a rainy day, whether the school opens, whether the school closes, etc. So we'll start. Let's talk about the temperature. Fine. So the table is simple, independent, dependent. You don't have to bother too much about these now. Let's take this temperature. This is actually in Fahrenheit. So if it's 70 Fahrenheit, he sells 100 lemonades. So the thing is that as temperature increases, like people want to hydrate themselves, so the chances are high that his sales will be high. I mean, sales will be more, right? So at 70 Fahrenheit, he sells 100 lemonades. At 75, 150. As temperature increases, his sales also increases. Fine. Basically, what is the most important thing here? Like for him, for like the Mr. Bean, what's the most important thing? The most important thing for him is the sales. He doesn't care about the values here, but he want how these values affect the sale numbers. So this is simple. Like this is the main dependent component which he wants to know. And there are some factors. Independent is more kind of a factors that are affecting this dependent variable or the sales. This is basically linear regression. So linear regression is a statistical method used to model the relationship between one or more independent variables and the dependent variables. Simply, there is a dependent variable, right? End of the day, he want to know what his sales will be. So independent variable are the factors. Temperature is a factor. Whether it's a rainy day or a hot day, that is a factor. Whether there is a playground near the shop, that is a factor, because there will be more kids playing. After playing, they might buy a lemonade from him. So independent variable is more kind of a factors affecting dependent variable. So dependent variable here is sales. Independent variable is temperature. They can be independent variable can be like anything, right? As I said, so it depends. This is simply linear regression. There is a dependent variable, which is in our case sales. There is an independent variable, which is a temperature. How temperature affects the dependent variable. That's it, linear regression. The thing is that only catch is that it does have a linear relation. So let's assume, yeah, I'll simplify things. Let's assume temperature increases, sales increases. Fine. Temperature decreases, sales decreases. That's it. It does have a linear relation. It doesn't interpret more complex relations. It's basic. You just be aware of this graph. This graph is not that important, but still, it does have a linear relation. Fine. One increases, the other increases. One decreases, the other decreases. It cannot interpret more complex ones. That linear regression. So there was I'll briefly conclude once again. There is a small lemonade stand. He wants to know the number of sales he is making. So that is the main objective he have. He then finds what are the other factors that affects the sale. Those are the independent variables. There are two components: dependent, independent, and this can be only in this can only have a linear relation. Fine. Yeah, this might seem so complex, but it's super simple. Why? What is Y? Sales, right? 100, 150, 200, 250. So these we can see this is like a case. This is case 1, this is case 2, this is case 3, this is case 4. Case 1, what is the sales? 100. What is that? Dependent. 100 is equal to, this is beta 0 plus beta x plus error. To simplify things, error, beta 0 and beta, the values of these variables will be given to you in the question. So it depends. Here the x is the independent variable and y is the dependent variable. I'll explain once again. Y is the dependent variable. So 100 comes here. Independent variable, x is the independent variable. So 70 comes here. This beta is the coefficient of x. Fine. Beta 0 is actually intercept, but I think I'm not getting into that so deep, but this is the basic structure. If there is like any question to find the linear regression, the format is that simple. You will get the x value, you will get the y value, and they will also give the beta and beta 0 value, and you just need to put that into this equation. Simple. Dependent is equal to independent. Beta 0, you consider it as beta 0 itself. I'm not diving deep into that. Plus beta x, coefficient into independent variable, plus error. Fine. This is all about linear regression.
So in this, sorry, but so in this, can we get multiple dependent variables?
Yeah.
Oh, sorry, independent variables.
Correct. I'm
beta x1, x2.
Yeah, I'm basically coming to that. So that's what I was about to say. Like, what if Mr. Beam want to consider, let's say, another factor? Okay. Now he is like dependent sales is equal to factors affecting independent, only one variable, right? Only temperature. What if he want to consider another factor to make good interpretation? So if he have more factors, he can make better decisions, right? So that's a whole objective. What if there is another factor? That's where multiple linear regression comes. So these are actually simple. This is basically a simple linear regression. There is one factor affecting and there is one dependent. Dependent will be always only one, right? There is one factor affecting the sales. If we have one or two or more, we will consider it as a multiple linear regression. Actually, there is like no difference between simple linear and multiple linear, except there are like the other one we consider more factors. Here we also consider the foot traffic, which means the number of people walking beside his shop. So beta 0, it is always the same. In here also you have, here also you have. Here you have the error term, here also you have the error term, basically same. Y will always be same, dependent variable, right? Next, you will be having beta 1. x1. X1 is the first independent variable we considered. To make better decision, he also started considering the foot traffic. So it's x2. The thing is that if there is a question that predict the sales that Mr. Bean makes, so the question will provide beta 0, beta 1, x1, beta 2, and x2. Otherwise you can't find those, right? So you just simply put that into the equation. You must be aware of the equation. That's it, simple. So once again I'll explain. Dependent is equal to factors or independent variables. Y is equal to beta 0 and plus error, which is constant. Even if the question doesn't provide the error term, it's fine. I think in midterm there were questions where the error term was not provided. That is fine. Secondly, you take beta 1 into x1, here 70, beta 2 into x2, 100. So you will get the value. Fine. This is linear regression. This one is simple linear regression. This one is multiple linear regression. That's it. So, and for like in an exam perspective, you won't be getting a table kind of thing. It will be like a question like Mr. Bean want to find his or predict his sales. Beta 0 is this value, beta 1 is this value, the beta 2 and x2 are these and these. Find the predicted value. So you just need to put all those value into the equation and you will get the y value. We will solve that kind of a question today. That's it. I think the linear regression is fine, right? Simple. Once again, lastly, you have a dependent variable. You will be having one or more independent variable. Beta is the coefficient here. X is the independent variable here. You have an error term. The only thing is that, only negative part is that linear regression cannot interpret complex relations. So if temperature rise, sales rise, it's fine for linear regression. Temperature lower, sales lowers, it's fine. But more complex kind of a scenario, linear regression cannot interpret well. There can be mistakes. Hereby we'll conclude the first part. So what was our agenda today? Linear regression theory and practical. Practical, you now know, right, which equations to use. Y is equal to beta 0 plus beta into x plus error term. If there is more variables, you will add accordingly, like beta 1 into x1 plus beta 2 into x2, fine. You just put the values and you get the answer and done. Next is the most important part, the theory part, which is the assumptions of linear regression. So basically, there are a few assumptions backing linear regressions. So these 5 assumptions should be met to get a much good or accurate data. So what are those assumptions? So this is so important. Like I think there can be 1 or 2 questions from this side. You just, even if you want to by heart, you just by heart everything, it's fine. So I'll briefly explain. Linearity. Relationship between variables must be linear. So here it talks more about a variable kind of factor, right? Fine. Independence. Residuals should not influence each other. It's talking about residuals. Residuals means errors. Fine. Homoscedasticity. Yes. Residual should have constant variance. Fine. Residual should not influence each other. Residual should have constant variance. Fine. Normality. Residual should be normally distributed. So these 3, it is major. The major factor is residuals. One, it should not influence. It should have constant variance. It should be normally distributed. Last one is about the variable itself. Independent variables should not be highly correlated. So first and the last one, we are talking more of a variable considering the variable factor. The middle 3, total there are 5 assumptions. First one and last one, we are talking of variables. Variable should be linear. It should not be highly correlated. Between these two, we have 3 where we mostly consider the residuals or the error parts, right? So it should not influence each other, it should have constant variance, and the residual should follow a normal distribution. A simple trick to remember all these 5 points, just be aware of this statement: learn is hard, notice now. So what is it? Like for the L, we now have a framework that, firstly, we know that assumptions of linear regression is so important. There can be and there will be 1 or 2 questions. So we know, like, we have like 5 assumptions. First one and the last one, we talk more of the variable side. The middle 3 we are talking about the residuals or the error side. So what is this? Learning is hard, notice now. What is L? L, before first term, first we are discussing about variables. So variables, first term is L, linearity. Variable should be linear. Second, I. Second is about residuals. I, independence. Residual should be independence. Both are similar statement. Residual should not influence each other, or residual should be independent is also same. Third, hard, H, homoscedasticity. You must be aware of the definition of homoscedasticity. Residual should have constant variance. If they don't have constant variance, it's heteroscedasticity. So our main focus is whether the assumption, whether the data is following this assumption, homoscedasticity. So learning is hard. Notice now, and we are again talking of the residuals or the error side, normally distributed. Residuals are normally distributed. Last we have again n. First and last we are talking of the variable side. So last n is what? No multicollinearity. That is, the variable should not be highly correlated. So learning is hard. Notice now. So first and last, we are talking of variables. The middle 3 we are talking of the residuals or error part. Simple. Once again, what is learning? First one. Learning. Firstly, we are mentioning, or we are considering variables as a factor. So variable should be linear to each other. I. Second one is what? Residuals or errors. So it should be independent to each other. Hard, homoscedasticity. Residual should have constant variance. N, normal distribution. Residual should follow normal distribution. N, no collinearity. Variable should not be correlated with each other. Right. I think it's fine, right?
The residual terms you're mentioning, you're talking about the error terms, am I correct?
Correct. Yeah.
Okay, thanks.
Could you please explain that error part again? Residual of error, what is that? I could not understand.
So residuals is another, you remember, like, residuals is another term for error. Residuals and errors are almost similar, like they are similar. So if you consider it as errors, it's fine. Both are same. So residual
it is
should not.
that E term that was in the formula, that.
Which one you're talking about? The equation?
In the equation, there was that E term. The residual of error is that part, or what?
This one itself. This E.
Yeah, the residual of error, that part you were talking about, is this term.
Is which?
You are saying that the residual of error, that part.
No, not residuals of error, residual or error. The thing is that they both are same. You can call, yeah. The
so
thing
what
is that,
are these errors? I'm asking that.
like, to get, I'm not like diving deep into this because we have time constraints, but simply to get a better result or an accurate result, we should leave some space for an error. So we'll add that error into the equation.
Oh, okay, okay. Thank
That's
you.
it. Just the factor is accuracy. This also beta 0 also, there is whole another concept that is backing why there is beta 0, but I'm not getting into that. It's like if I explain, it's simply that I'm complexing the equation.
Right,
So
okay.
you will get the I think you will get the what value for beta 0, beta 1, beta 2, and if there is error, you will get the value.
Okay,
Beta
okay.
0, you can remember like beta 0 means intercept. intercept, intercept. You can remember the word, but I don't think you should get into that.
All right, all right. Okay, thanks.
So,
That's good.
so here we conclude linear regression. We have two, like you should be aware of that image, the person selling lemonade. So we have sales as a dependent factor, and we have the weather as an independent factor. So the equation comes to y is equal to beta 0 plus beta into x plus e, where x is the independent variable, y is the dependent variable, beta both are like coefficients, and the last one is error. Linear regression done. Second is the 5 assumptions of linear regression, where you remember this line, learning is hard. Notice now, where the first and the last, we are talking of the variables. The three in between those two, we are talking about the residuals. Fine. Fine. So now we'll start. I think I've revised everything. Linear regression and the assumptions of linear regression. I'm saying again, like the assumptions are so important. You will get, it's a theory concept, and you will get maybe 5 options. Out of 4 are assumptions and 1 will be wrong, and you might be asked to find which one is wrong. So if you have like these 5, if you know these 5 assumptions, you can find that other one easily, the odd one easily. Linear regression done, assumptions of linear regression done, fully basics. There is some practical side which we'll be discussing next. That's it. Next what? Logistic regression. So simple. In this case, his main, what we would say, no, basically he want to know the sales at each stage, or considering each independent factors, what can be his sales. Let's assume he's not that good at statistics, and he was like, he's like, he know like whether the temperature is high, he know yes it is high. Whether the temperature is low, he know like yes it is low. Whether there are more people in the footpath, yes there are. So he only know whether it is right or wrong, yes or no, success or failure. He don't have much data. In that kind of a situation, same, exactly same like linear regression, but the case is different where he doesn't have much data. In that kind of a situation, he can use our next topic, logistic regression. So in logistic regression, it's basically same, like almost same, used when the independent variables categorical, often binary. The other one, the data is continuous, simply numbers. Here the data is success, failure, yes or no. This is logistic regression. This is one of the major part in this whole module 2. So unlike linear regression, see, no, these 3 points are so important, but these are simple though. First point, I think you might have what understand. The thing is that the other one, he have some data. Here he doesn't have much data. Second point, in linear regression, the data can be like anything. like 10, 100, because sales, the number of sales, he is getting a value for the number of sales, right? Sales can be 100, sales can be 0, sales can be 1000, 2000. So there is no end to it. But in logistic regression, we consider the probability. Simple. In logistic regression, we find whether the data is a categorical one. Yes, no, success, failure, etc. And the end result which we get will be in a probability form. It can be like 0.8, that which means the probability is 80% that his sale will increase. Fine. For in order to find this probability, we use the logistic sigmoid function. Again, I'm not getting into what sigmoid function is, etc., but you just be aware that to model this kind of a probability or getting result in a probability form, we are using the sigmoid function. That's it. You guys read this slide once. Fine. So same case. He need to know what his sales are, but he is not quite good at statistics. Earlier case, he's quite good at statistics. Now the scenario changes. He's not that good at statistics. He knows yes, no, success, failure, that kind of a reply. So for this kind of a scenario, we use logistic regression. In what form the result will be? In probability form. How this result, how we are able to get this result in probability form? Using the sigmoid function. Done. This is just the graph for sigmoid function. It is an S shape. Sigmoid S. Just be aware of it. It's not that important. Just be aware of it. This is it. Is it a hot day? Mr. Bean, have an answer? Yes. Is there a playground? Yes. Is there money with the customers? Yes. Did they bought the lemonade? Yes. So there are 4 cases, out of which it's a hot day and there's a playground and the customer have money, they bought a lemonade. So there can be some sales happening. Even for the sales, he doesn't have much numbers, right? So for the it's not a hot day, there is a playground, they have money, then yes, they might buy some lemonades. So we'll basically find the probability that, yeah, there are like 80% chance that they will buy lemonade. So we'll find the probability for these 4 cases. That is basically logistic regression. Simple. Before that, we'll get into a concept known as odds. This is a simple topic, basically explaining odds is equal to probability of something happening divided by probability of something not happening. That's it. If there is a 50% chance that he makes a sale, fine. 0 probability of making a sale, 50, 0.5 divided by probability of not making a sale, 1 minus 0.5, which is equal to 0.5 by 0.5, 1. We will do some practicals from this side. We'll start it now. Before that, there is another side, log odds. Log odds are the natural logarithms of the odds. Fine, by the name itself, you might be knowing. Logistic regression expresses log odds as a linear function of independent variables. You just be aware of this statement. Logistic regression expresses log odds as a linear function of independent variables. So for the log odds, the equation is simple. The odds, no, this, we put that inside a log of odds. That's log odds, which means log of p divided by 1 minus p. Log of p divided by 1 minus p, log odds. Simple. Now I think There's a comparison, meaning ratio of success to failure, logarithm of odds, 0 to positive infinity, the value will be 0 to positive infinity, and minus infinity to plus infinity. Rarely modeled directly. So I think this is basically found in order to find the log odds. So used in logistic regression. These are rarely used as an individual one. So let's get into the calculation. These are basically simple one. I'll also.
Can you please explain the range here?
What?
Can you please explain the range 0 to positive infinity and negative infinity to positive infinity?
Yeah, range basically means the answer you will be getting will be from 0 to positive infinity. No, we are basically the two values are basically positive, right? So you will be getting a positive value, right? So for odds, the range, the answer will be from 0 to positive infinity. From 0, the values can be anything. For log odds, it can be negative to positive infinity. One second.
Okay, right.
Huh. Can you guys see my screen?
Yes, sir.
Can you see the calculator?
Yes.
Yes.
Fine. Now we have some questions. Excel is visible, right?
No, the Excel is not visible. Only the calculator is visible.
Okay. Fine. I'll screen my Excel first. Now is it visible?
No, sir.
Yes. Now,
Yeah, now it's visible.
Excel is visual.
Fine. So we have questions on odds and log odds. This is actually simple, right? The equation is P divided by 1 minus P. Probability of something happening divided by probability of the same thing not happening. Log of the odds. Log of P, probability of something happening divided by probability of the same thing not happening. So we have a question. So they'll give like the probability is 0.8, find the odds. So what is the odds? 0.8 probability of something happening divided by 1 minus probability of the same thing not happening. 1 minus 0.8. Fine, right? Probability of the same thing not happening. So we'll get the answer as 4. So 4 is the odds of the probability 0.8. Done. We'll find this last. Again, next question. 0.25 is the probability. Find the odds. Fine. 0.25 is the probability divided by 1 minus probability of not happening the same, and 0.33333. This is the now we found the odds of these two questions. Quite simple. This comes under, once again, this comes under the logistic regression session. This is our very first practical question. Fine. We found the odds. what is the log odds? For this, I'll remember like the first value is 4, odds 4. Second, we have odds is 0.333. Now I'll share my calculator. Calculator visible, right?
Yeah, it's visible.
Yes, Rohit. Yes.
So for first question, where our probability was 0.8, we got the odd as 4. So we need to find log odds. 4, there is an ln section, which means natural logarithm. You need not, you don't want to, there is no requirement to know what that is. Just apply ln, you get the answer. 1.38 is the answer for first one, where the odd is 4. So I'll write down the answer. 1.38 log odds for probability 0.8. Fine. Next, we need to find, second we have 0.333 log odds of this one, 0.33. Again, this, I think this will be the same calculator we'll be getting for the exam too. So just press ln, done, minus 1.0. Is there any issue because we have a negative value? No, because we have already discussed that for a log odd, the value can be negative infinity to positive infinity. So it can be negative. So you can just re-verify your answer from like that perspective. 0.98. Done. So we got both the answer. My screen is visible, right, Harshit?
Yes, Rishabh, it is visual.
So the log odd is we got for the first one 1.38, and the second one we got minus 1.098. Simple, right? These are like basic calculation, but you must be aware of the only thing you can be wrong is this thing. One second. Is my calculator visible?
No.
Okay. No. Though these are quite simple. You just be aware of these two equations. Even if you are aware of this equation, you just need to add log, right? This is one practical kind of question which we'll be getting for the exam. Odds and log odds. Quite simple. P of probability of something happening minus probability of something not happening, odds. Log of odds. Log of this odds. Probability of something happening divided by not happening. And this is it. Our first practical. Next. Yeah, I would say the most important thing is that just a second. The most important thing is that this log value, because you should be pressing this ln key, otherwise your answer can be wrong. Let's assume if I wrote 4 log, I'm getting a different answer. 4 log yx, you won't be getting anything. So you should be aware of, yeah, again different answer. You should be aware of, we should be taking the ln tool. Ln. I'll confirm this with the professor or the DB team once again, because I found that we should use the ln on the scientific calculator on Google. So I'll just confirm if there is anything wrong. I'll let you know. As of now, I'm quite sure that we should use ln, but I'll re-verify that. This is it for the odd section. Are you guys getting something? Fine, right? You guys are on track, right?
Yes.
Yes.
Right. Am I going so fast or something?
No, it's all right.
Okay. So, um, my presentation is visible or not?
It is visible.
Fine. This is odds versus log odds. So logistic regression, we have discussed what logistic regression is. The function which helps to make or give a probability or an answer based on a probability. And we explained odds, log odds, cross-validation study. This is a theoretic concept. Basically, if we get a data, let's assume I got a data, I split the data into two, and first one I use for training. So to get the like what conclusions or results, then the other one or the other part I'll use for testing. This is basically cross-validation study. To goal is to evaluate how well a model performs on different subsets of the data, ensuring that the performance is consistent across different data display. Simply just to improve the accuracy of our conclusions. Fine. We'll be having a data, we split it into two. One we use for training, one we use for testing. What's the purpose? Accuracy. Logistic regression. This is the practical part. This is like we majorly have three practical parts. Linear regression we have, but it's a small one. We can do one or two questions. Log odds and log odds we have already done. Next is regression, logistic regression. This is a process, or the equation is a bit complex, but it's super easy to solve. Just a minute. So we have this data, right? Mr. Bean provided this data to us. There is yes, 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 yes. Hot day, yes. Playground, yes. Has money, yes. So will someone buy a lemonade? Yes. So he have four cases, 1, 2, 3, 4, and he have four conclusions also, right? All in a categorical form, right? Yes or no, success or failure. That's basically categorical form. Fine. Then how will we find the probability? I mean, which equation to use? This is the equation. Sorry. This is the equation. So it feels like too complex, but it's simple. Basically, 1 divided by 1 plus e raised to minus, what is this? Like, basically, what is this? What do you think this is? This B0, B1. B is basically beta. B0, B1, X1, B2, X2. What is this? Just reply.
Independent
Linear
variables.
regression.
Come again?
The formula for the linear regression.
Exactly. Right. So you remember like 1 divided by 1 plus exponential raised to, exponential of linear regression. Once again, dependent variable is equal to, probability of dependent variable is equal to 1 divided by 1 plus exponential of linear regression. Why we use this part out here? To get the answer in a probability form. Simple. We'll get into the practical part. If you have any doubts, just ask, like while I'm explaining itself. No issues. So I'll go step by step slowly. I'll share my Excel now. For this practical question 2, I'll be using the scientific calculator, which will be getting exponential part and all. We'll be using that itself. My Excel visible or not?
Yes, it is suitable.
Fine. So we have discussed the odds and log odds part. This is a question, right? This is a particular case of Mr. Bean. So we have the equation here. Now we'll solve together. So for the question, I've already mentioned that beta values will be provided. No issues. If there is an error also, you will be getting the value for that. No issues. So beta is provided. The same data we have will answer. Okay, we are starting to solve this from step by step, each step. If you guys have any doubts, you just ask. So first thing is that these are in yes or no form. So how can an yes or no form how can we use this yes or no form to find the probability? We can't, right? We need some number or numerical form. So what we do is that we'll say, like, for yes, I'll take as 1. For no, I take as 0. Fine. What is this? This is step 1. So if you guys get this kind of equation, step 1, I make it somehow into a numerical form. So next what I do is that I'll copy this. So I need to convert this into this form, right? For yes, it's 1, 0, 1, 0, 1, 1. Fine. First step, we solved first step, right? So we converted this into some numerical form. We got this, right? Next, what's the step? We'll use the equation. Fine. So what's the equation? I'll copy this. So we have an equation. This is our equation. So first step, we found we've changed the yes or no to 1 or 0. Next is simply we'll find initially this part. We'll find the linear regression part. Fine. Okay. So step 2. In total, we have how many cases? Just be aware, each row is a single case, right? Hot day, playground, these all are a single case. So in total, we have 4 cases. I'll write like, I already have like, step 2, case 1. So I'll solve the linear regression part. So I've not done practicals in the linear regression part is because here also we are doing the same problem. Okay, so this can be like a linear regression. You can consider this also a linear regression problem. So for case 1, I'll find this, right? B0. What's B0? B0 is already given in the question. 0 0.5, 0 0.5, 0 0.5. All are 0 0.5. So I'll do 0 0.5 plus beta 1 into x1. Beta 1 is what? 0 0.5 itself into x1. We know in first case all variables are 1 itself. So it's easy. 1 plus beta 2 is 0 0.5 into 1 itself plus beta 3 into 1 itself. We getting linear regression. This is a linear regression. value, we are getting the linear regression value as 2, right? We'll find this for the other 4 cases. It's 2, case 2 is equal to, okay, B0 0.5 plus 0.5 into, we have 0 here, fine, right? We have 0 here, which is x1, 0, again plus 0.5 into, we have 1 here, 1 in plus 0.5 x3, I mean b3 into 1 itself, right? Yes, 1.5. For case 3, again we'll solve in the same way, is equal to same 0.5 plus 0.5 into, what's the first value? 1 plus 0.5 into
Rishabh,
second. Yeah.
in the exam, the kind of questions we get, वहाँ पे भी will be given, the table will be given in yes and no's.
Yeah, correct. It can be yes or no, or it can be success or failure. You can convert that into the 1 or 0 format.
So it will be always these 2 types only.
Yeah, that's it.
Okay.
0.5 into 0 into 1. 1.5 again. Case 3. Basically, what I'm now what I'm finding, the linear regression part, right? The equation is 1 divided by 1 plus exponential of negative linear regression, negative value of the linear regression. Again, 0.5 in plus 0.5 into 0 plus 0.5 into, this is basically an exercise to find the linear regression part itself, because this mostly this can be the same format. You will get these 4 values, you will also get the values of x1, x2, x3, you will get the y value, right? That's it. Beta 2, x2, x2, 0, 0 itself. 0 plus 0.5 into 0 itself. We get the answer as 0.5, since the other 3 values are 0 itself, right? Now we found out step 2. We solved step 2. What was step 1? Simple, convert into a numerical format. 0, 1, 0. We used 1, 0 to convert into a numerical format. Next, what's the case? We found the linear regression part. B0, B1, X1, B2, X2, B3, X3, etc. The next step is basically to find the exponential, which is the major part, right? So I'll do one thing. How to do the exponential part using calculator? What is exponential? Be conscious or be aware that there is a negative sign here, so you should consider the negative value of this. That we'll do in the calculator. So we have 2, 1.5, 1.5 and 0.5 as our values. So we'll solve. Scientific calculator. No, this is simple, right? There is the calculations are so simple. You just be aware of the steps. If you know the steps, then it's simple. The only mistakes that someone can make is if she use log 2x instead of the ln, or for exponential, if there are e1, e2, e and exp. So we must be aware of which sign we need to use in this calculator. That's the most important part. Other all, I think it's fine. So what we'll do, we'll take case 1. Okay, case 1, we got the linear regression value as what? 2. So what we'll do is that we'll do minus 2 equal to, we getting 2, right? Minus 2 as the answer. So exponential of minus 2 is what we want to find. For this, we'll use the e raised to x. Once again, e raised to x. We'll click on this now. Yes, I got the exponential of negative linear regression value. What's the value? 0.135. Next, what is there? Simple, right? 1 divided by 1 minus exponential of negative linear regression. We already found the difficult part, right? So we just have to do the basic calculation, which is 1 divided by 1, or I'll do 1 divided by 1 plus, what is the exponential value of the linear regression we got? 0.135. Done. What's the answer? 88. You can verify this whether it like more kind of a verification method. If it lies between 0 to 1, mostly your answer will be correct. If it's not, it is wrong, because we need a probability, right? So the probability of making a sale if all 3 are yes is 88%. So the answer is 0.88. So I'll note it down right now, because I can't share 2 screens at a time. Next, we have second case where we got the linear regression value as 1.5. Simple. First, minus 1.5. There is one thing after, now what I'm doing is minus 1.5. I'm clicking on the equal, because if I write, I'll first do this, and then you should click on the equal sign. Then you get minus 1.5. This is the final value you are getting. You get minus 1.05. Then you put the exponential e raised to x sign. Yes, 0.223. Exact. 0.223. Next, what is there? Simple. 1 divided by 1 plus 0.223 is 1.223. Answer is 81%. 0.81. The thing is that if I do, no, I think usually we have what? Like a button to include this negative value in the calculator, but now I'm not seeing that. That's why I'm doing this minus sign, minus 1.5. And if I don't press the equal sign and I do the exponential directly, the answer is 4.48. The actual answer is 0.223. It's because 1.5. Like, we have not clicked on the enter key. So first process minus 1.5. Click on the equal sign. Then you find the exponential. Now the answer is different. Fine. I'll note that down in the Excel sheet also. So we got 0.81. So third case, we have 1.5 itself. So the probability will also be same, right? But still we'll find minus 1.5 equal e raised to x 0.223, 1 divided by 1.223, same answer, 0.81. Lastly, we have 0.5. 0.5 minus 0.5, what is minus 0.5 equal e raised to x, we got 0.6. Now what? 1 divided by exponential of negative linear regression. 1 divided by 1.605. 62.3%. So Fine, right? For the odd equation, or to find the log odds part, we use the ln, right? Okay, fine. We use the ln. For the exponential part, we use the e raised to x, this key out here. Please be aware of this. This is so important because already there are like 1, 2, 3, 4 log signs and 3 exponential signs or e signs. So you might get confused. This is the exact same calculator if the software is the TCS one. So e raised to x, ln is logarithm or natural logarithm or something. Fine. Now we can edit the Excel. This is it. Like, this is the main practical part in this module, and this module is almost completed. Actually, it's easy. The linear regression part is connected to the logistic regression. You just need to be aware of this equation, the linear regression equation, log odds and odds equation, and this one, logistic regression equation. One, case 2.
Lisa, what is the answer that was in the question that was in the chat box?
Chat box.
Yeah, like, so they not use E symbol. What is its
No,
answer?
e raised to x. E raised to x. No, I've shown you, right? Like, wait.
Okay.
Once again. Like if you want to note it down, please note it down. This is so important because even if you know the equation, there is no point. E raised to x for the logistic regression, not e raised to x. There are 2 elements. For ln2, there are 2 elements. Both are alphabetic. ln ex. The ln part, I will re-verify. If there is any, I think it is correct, but if there is any changes, I'll surely let you know. Oh, no. So, case 4, we got exponential value 0.135, 0.223, 0.223, 0.605, and we found the logistic. Then we find the logistic regression. Case 1, 88%, 81%, 81%, 62.3%. Done. In total, we have 4 steps. Simple. It's actually quite simple. See, first step, you will change the yes or no to some variables, 1, 0. You have a new distribution data, right? So, or the new data, new table. So here we have the equation. We'll first do the linear regression part. So step 1 done, step 2 linear regression, step 3 exponential, e raised to x. So you do negative number, you press on the, or you click on the equal button, then you will get the negative value, make that into ex, e raised to x. So you'll get the exponential value. Then logistic regression, how 1 divided by 1 plus the value you have here. So 1 divided by 1 plus 0.135. So you'll get the answer for the logistic regression. So what are the conclusions here? It's not that important, but we'll make, right? Yeah. So, so all 4 probabilities are above 50%. So I can say that all this there is a chance that all these 4 might have happened. No, this is actually a made up example. So these are values that I gave for simplicity. So there is a chance that all four might happen, or 4 cases might happen. Simple. First find the change into the 1-0 format. After that, linear regression, exponential, logistic regression. Please be aware that you should use the ln function on calculator. I'll verify this, and this I'm sure, e raised to x in calculator. That's it. And also one thing, before this, right? Enter minus linear regression value, press enter. Please don't forget to press enter. Then you find the exponential one. So you get the correct answer. These are 3 main factors where you might get wrong. If you are aware of these 4, then it's just equating in the equation, right? This is one second. Now that's basically the major practical part. We don't have any other practical part in module 2. Like we having
Excuse me.
like, yeah.
I've tried that 1 divided by 1 plus thing, but I'm not getting the same answer
Yeah,
as yours.
the thing is that I've done in a way that 1 divided by 1.2, including like by adding the value, right? You, if like I'll yeah, good question. I'll also share that. Scientific. No, the thing is that like 1 divided by, I'll take the first case, 1 divided by 1.35. So yeah, 0.135. 1 divided by 1.135. Yes, this is what I'm getting, 88%. So for her, the thing is that 1 divided by 1 plus 0.135, the answer is different, right? Why? If you are doing like this, no, there can be some like confusing value. If that's the case, you should put a bracket, right? Then you do 1 plus 0.135, close the bracket, equal 88% itself. Fine. Now, if you are doing like this, I've done mental calculation. If you are doing like this, you should. That's also an important point, actually. You should put the brackets. I'll include that too.
I'm sorry, and after step 4, how did you convert that back to the yes or no criteria? Like if it is 88% and then you said yes, it may happen.
Yeah,
So
I'll explain that. One second. Yeah, for here 1 divided by bracket open 1 plus exponential value. Bracket should be there. It's important. If you're doing mental calculation, it's fine, but no, it might lead to confusion. Like you just remember this whenever you are like, no, whenever you are calculating the last part, you just put a bracket out there. You do like this itself as per the equation. So there won't be any error. So first thing, yeah, enter the negative linear regression value, press enter, then you find the e raised to x. Then you will do 1 divided by, in bracket or within brackets, 1 plus that value. Fine, right?
yeah, that's fine. I was asking about right here where you wrote 4
This
times
right?
yes. Yes. So how
No,
did you
this is,
manage to conclude that yes, it will happen?
yeah, I'll explain. What is this actually? I'm asking you itself. What is this actually? These numbers?
That's the probability of these event happening. The
Correct.
dependent variable.
Correct. Correct. No, this is basically no. We are making a conclusion from the value we got or the values we got. What is the conclusion? 88%. If it's X is greater than 50%, which means that that event can happen. There are chances that case 1 might happen. If the X value is less than X value less than 50%, we'll say no. The chances that this might happen is very less. So no, this might not happen. So based on this, I mean the probability, we say like 88%. Yeah, it's above 50%. So we'll say yes, this might happen. 81%, this might happen. 81%, this might happen. 62, this might happen. All are above 50%. If there's a value of like 40%, what we'll say? No, this might not happen because the chances are very low. Like it's more kind of a conclusion based on this probability. It's
Okay,
not
understood.
necessary. It's not necessary, but just to interpret the data, it will be helpful, right?
Yeah, got it.
Please explain the
This
step 2.
which one?
Step 2.
Step 2. Okay, fine. Yeah, if you guys have any doubt, please ask now itself. No issues.
Explain about ln again, please.
Yeah, fine. I'll. Step 2 is
Hi Rishabh.
what, Harshit?
Hello.
Oh yeah, Albin. Yes.
Anu, yeah, can you just show the question how it would be? This particular question how it would come in the exam? That the text part.
Which one, Albin? Which one you're talking about?
No. The question part of this one.
Yeah.
The problem which you're solving right now. Can you show that?
This one, right?
Yeah. What would be the text in that question? What would be the textual part of the question?
The question will be of like if there is no table, what kind of a question we can expect, right?
Correct.
Okay, I'll explain all that too. First, we'll explain step 2. Step 2 is linear regression. What's the equation for linear regression? We have right here, right? We have already discussed in the first part. Linear regression is beta 0 plus beta 1 into independent variable plus beta 2 into x2 until this can be infinite based on how many independent variables we have, right? So we have all values, right? We have beta 0, it's already given in the question. Beta 1 is given, beta 2 is there, beta 3 is there, and there are 4 cases where x1, x2, x3 for all or each cases are given. So we just use this equation and we find the linear regression value. What's it? 0.5, which is beta 0, plus this should be also in bracket. If you are doing in a calculator, if the numbers are a bit complex for the mental calculation, you might use that brackets. So 1 second. So first is beta 0, already given in the question. 0.5. 0.5 beta 1, which is already given, into 1 where we got that 1. First step, we have converted the values. Here x1 is 1, right? X1. Same, beta 2 x2, beta 3 x2. Case 1, we have completed. What linear regression value we got? 2. Fine.
Same for case 2, same for case 3, same for case 5. So basically we are putting values into this part. Simple. But just be aware, like, better you put this in bracket, because again, if you are doing in calculator, the answer could be wrong.
Okay.
Simple.
But professor gave us the formula for probability was e to the power beta 0 plus beta 1 x1 by 1 plus e to the power beta 0 beta 1 plus x1. Beta 0 plus beta 1 x1. Is
Yeah,
there any
just
difference?
like for I didn't got your question first.
Professor gave us a formula for probability. Which one you are
Yeah,
showing? 1 by 1 plus e to the power beta 0 plus beta 1 x1.
not e to the power exponential of the value of this.
Okay, exponential of that value. But professor gave us exponential of the value of beta 0 divided by 1 plus exponential of the value of beta 0 and that.
Beta 0 by once again,
Formula
can
which professor gave was exponential of beta 0 plus beta 1 x1
beta 1 into
divided
x1,
by
right?
beta 1 x1 till beta n xn. Okay.
Yeah.
And then divided by 1 plus exponential of that same value, numerator.
Can you put that on the chart? No, I don't know whether there is a second method, but this is correct. No, we'll see. No, the thing is that we'll use this equation for a midterm question, so you will get a good clarity. No, I think this is correct itself. This equation is correct because I've used this same equation for the midterm. So the answers are same. Actually, to be honest, I don't know whether there is a second equation. That's it.
Hi, like the probability formula that I have been using was 1 divided by 1 plus e to the power minus log odds. And I checked several times, the answers were same only. And I checked on GPT and DeepSeek everywhere, and it was showing that only.
E raised to what?
E raised to the power minus log odds.
Minus log odds.
Yes.
You are getting the same answer itself?
Yes, for every single question, I'm getting the same answers.
Which means that.
And I've been calculating, I'm sorry, let me complete. I've been calculating log odds as beta 0 plus beta x1 plus beta x2, x2, whatever, like till infinite we can take, right? So I've been calculating through that. So I did a sample paper and I did the midterm questions through that only, and the answers were same.
Same, right? Then no issues, right?
I want to know if I can do that way in exams also, no? Like the things that you are teaching was different from what I got the answer. So I want to know which is the correct one.
Okay. So what you're saying is that there are like multiple methods, right?
I was saying that the method that the guy recited before, I've been using that one and I'm getting the same answers.
Fine. If you can put that on the chat box, I can like mention it here.
Sure.
So the thing is that no confusions. There are like two methods. You can either use this or there is another method which I'll add here somewhere within some minutes. So the next doubt was, so Alvin, what was your doubt? I forgot. Yeah, question format, right?
How would this question come in the exam? How would the question look like?
Got it. So for in the exam, same, instead of these four cases, you will be getting a single case. You won't be having a table or something. There can be two types. One, the same way what we did, like you will be having this kind of a table and you should follow this entire process. The next step is you will be given the values directly and you just put that into the equation. That's it. There can be two ways. We'll solve like the second method or the second type of question in the midterm part. So there is one question, I guess. You will be much more, you will be having okay, fine, go. Shahzad, oh yeah, please. So we have, I'll mention that too. If you haven't watched any like modules or any lectures from this module, you better use this itself. If you know any like better or easy formula, you use those, because if I mention any other formulas now, you'll be confused, right? So I don't want that. So if you are like seeing this equation for the first time, you use this itself. Your answer will be same. Fine. One second. Um, yeah. So this is basically logistic regression. My screen is visible, right? PPT.
Yes.
Rishabh,
Yeah.
can we calculate log odds for this table?
For this one, using the log odds equation now.
No, like if you have to calculate the log odds for this table, is it possible?
If you have to calculate the log odds for this one, no. For log odds and the odds, we need some probability, right? Maybe we can use this probability. Like I'll say, we have 88%, right? Which is 0.88. What's the equation for log odds? 0.88 divided by 1, it should be in a bracket, 1 minus 0.88, right, is equal to this. Enter. Is equal to this. We get 7.3333. So if we want to calculate the log odds for the same, I'll share the calculator. 7.333, we'll type 7.3333 and ln, natural logarithm, we get 1.99.
Okay, right.
Fine, right? No, for log and log odds, we need some probability value. So to get, yeah, we need some probability value. Like in this equation, we need to find the probability, right? So we found like that. And what I was about to discuss, yeah, next. By this, I think we can conclude the logistic regression. So first we discussed linear regression, where one dependent and
You need to change your screen. We can only see the calculator.
okay, sorry. Yeah, first we discussed about linear regression, where there is an dependent variable is equal to independent variable. So the image you should have in your mind is Mr. Bean selling lemonades, dependent sales, independent temperature, whether there is a playground near his stall or something, etc. That's linear regression. Simple linear regression, only one independent variable. Multiple linear regression, multiple independent variable. Sorted. Secondly, we mentioned 5 assumptions of linear regression. Learning is hard, notice today. First and last, it's more kind of a variable context. The other 3 between these two values, we are considering the residuals. Fine. Next, after that, we discussed logistic regression. Simple logistic regression gives a probability value for categorical variables, which is yes or no variables. They'll give a probability value. How they give a probability value? Using sigmoid function. Done. Next, next we discussed odds and log odds. What is odds? Probability of something happening divided by probability of the same thing not happening. Log odds, log of probability of something happening divided by probability of something not happening. Just to confirm that, this is the same equation what we used for finding what? Logistic regression. Same itself. Minus, instead of minus z is basically minus linear regression, that formula. Next, we are getting into, I think revision is done. Next, we are getting into types of non-linear regression. This is a simple topics and short one. Basically, non-linear regression is what? Like the relationship have, or the, see, that if temperature rise, the sales rise. Temperature decreases, sales also decreases. The thing is that they can't do much complex calculations, right? Whereas in non-linear regression, you can do like complex relations. So this is basically the graph which we saw in the previous slide. So this is a straight line. This is a bit more complex line. I mean, complex graph. Non-linear regression is used when the relationship between the independent variables cannot be accurately described by a linear model. Simple. This is a theory part. We have 4 types of non-linear regression. These are the 4 types. You just be aware of these 4. There can be some questions about what is polynomial regression or something, or like select the odd one, or select that option from the list which is not a non-linear regression. Okay, like that questions can be there. So you just be aware of these 4 things. There is polynomial regression. We use quadratic or cubic formula. Models non-linear relationships. There is an example given to each one of them. Demand changes with price up to a point and then decreases. Up to a point and then decreases. Exponential regression used for graph that decreases and increases at a constant rate. There is a constant acceleration or deceleration in the values. Logarithmic regression, model regression that grow quickly at first, then level off. Marketing spend. If you are a new business, the initial money you put out for marketing will need a good amount of sales for you. But after a certain point, it will start diminishing, right? You won't be getting much result from the same amount you invested earlier. Power regression models relationship where when variables changes as a power of another. Output increases with resources at a power rate. These are basically theory. We have nonlinear regression where which can be used to find complex relations or non-linear relations. We have 4 types which are mentioned in the module. That's it for the session actually. We'll do a quick revision and we'll conclude this module 2 session. Actually, I don't know how much time I took. I took almost 1.5 hours. I told like 75 minutes, but the thing is that it's actually simple. It's simple. Think like what is there? Nothing. Linear regression. We know Mr. Bean is there. He has some data. He is a good statistic person. And there is an equation. What is and we have like simple and multiple linear regression done. What is logistic regression? Mr. Bean is there. He wants sales data, but he doesn't have anything. He only know yes or no. Fine. We are finding using the equation we have for logistic regression. What is odds and log odds? There is a equation which is basically the definition for the same. We use that, find the odds or log odds as we require. Lastly, nonlinear regression. Theory part. What we have? 4 types of nonlinear regression. Done. So linear regression suitable for continuous data, basically numericals with linear relationship. Done. There's a straight line out here. Logistic regression, ideal for binary or categorical items. Yes or no, success or failure. Those kind of what outcomes. Non-linear regression, super complex figure out here. Best for complex non-linear relationships. That's it. This is actually simple. Like there are a lot of theory. I think the assumptions and all are super important, but the practical part is quite simple. These are the whole, 4 formulas we have in this module. Just get a look. I'll share the PPT to you guys. It's, I think, if you got something from this session, it's better to refer this PPT itself. So there is like a mental image for module 2. So each time you scroll, you have that mental image. Mr. Bean, learning is hard, notice now, equations, metrics. Yeah.
Sorry to cut you out, but before leaving, can you do one question from the sample paper?
Right now?
Yes. Actually, I've been having a lot of confusion because whatever you taught today and what I've been doing, they are completely opposite things. So if you can just do one small, like, I think 6th or 7th question is of log odds only. I don't want you to calculate the probability. I just want you to calculate log odds for that question.
Okay, fine. No, the thing is that it's already 8. We have also like said that we'll discuss midterm 1. So we'll see if we have time or we can do. Otherwise, we can include the sample question part after the next session, the session 2, which probably we.
No, see, it's already 8, right? And midterm 1 is like important also. So can we do that in the next session? Because I want to be like in a fresh mind. I've been sitting here from 4 o'clock. Brain is already fried. No new information is gonna go in. So instead we can do her question and end the session and like just see this is important. No, so maybe you all can do one section for one module and uske questions and then move forward. एक ही class में 2 module करना फिर उसका midterm करना is a lot to take in.
Exactly. The questions are from Logistic only in the sample paper. So if you can do that one question, then we can practice on our own.
Like end. And then next class we can do mid semester 1 and then module 3, module 4 and whatever is that. But ask them if they are prepared or not. We can't directly tell them. Yeah, but like if they want to, वो भी like option है.
Listen.
Yeah.
Like we will do midterm tomorrow, day after tomorrow. Just solve one question out from the sample paper.
Fine then, fine. Then who is that? Like, can you share that question?
Yeah, give me a second. Okay, Harshit, you are doing.
I will share my screen.
So we'll do one question and we'll end this session.
Can you do question number 8? I think. Okay, you're doing 6th one because the 8th one consists the both things that you have taught us today.
Then we should go ahead with 8th only, I think.
Yeah.
I think logically speaking, since log and exponent, like e functions, they are both inverse, right? So it makes sense, right, that both works in this equation. Both the log method as well as the exponent method should work, since we are doing it on a fraction scale. Since they are inverse functions, makes sense. It would be the same effect, regardless of the way we chose the last answer we get will be the same.
Okay.
We'll get the idea when we do it in practical so that everybody gets it clear. And logically, it makes sense, right? Since it's inverse functions, it's not wrong. Either of them, it's not wrong both ways.
Question 8, Harshit. Cool. Hospital wants to predict whether a patient is at higher risk of readmission. And it's one or no based on length of stays in days and number of based on length of days. So basically, yeah, we'll go through the question. A hospital wants to predict whether a patient is high risk of readmission. High risk, basically, the probability. It's mostly mentioning the chances that there is a risk of readmission. So we'll use 1 or 0. Yeah, fine. So it's basically a logistic regression question based on length of stays and number of chronic days, which are the two independent variables, right? The logistic model is intercept. Beta 0 is minus 3.2, 0.15, 0.8, cool, per condition. For a patient who stayed 6 days, length of stay is independent 6, two chronic conditions, that is also provided. Calculate the log odds of readmission. Log odds of readmission. Fine. So for finding log odds, we need probability. So for finding probability, we need to use the logistic regression. After that, we'll get the log odds. So I'll do this once more. Just a second. Let me copy this on my Excel. Hospital. We have length of stay, date, length of stay, chronic conditions. Length of stay. Chronic conditions. Um, beta 0, beta 1, beta 2, fine, cool. We have six patients who stayed, 6 patients who stayed for 6 days. Well, for a patient who stayed for 6 days.
What happened, Rohit? This of like my network is lost for a few minutes.
Sorry. No, I've started sharing the screen.
Okay.
My screen is visible, right?
Yes, yes.
Yeah, that's right. So first, we'll start with the linear regression part. Here we have values actually. We don't want, I don't think we should use yes or no. We'll see. First we'll complete linear regression is equal to 3.2 plus bracket 0.15 into 6 plus 0.8 into 2. Yeah, we only have actually case 1, right? Only one case. Fine.
Rishabh,
Minus
can you
0.
zoom in a little bit?
Sorry?
Could you zoom in a little bit? The Excel sheet. Yeah, works. Thanks.
Linear regression, we have minus 0.7. Next, we have to find the exponential value of the same. Exponential minus 0. Minus 0. Minus, yeah. Wait, see, we have linear regression. We got the linear regression value as minus 0.7. We already have a minus in the equation, so the equation will become positive itself. 0.7 e raised to x, 2.01. Enter. Next is what? Next is um, one. Is there any option 83%? Harshit?
Yes, yes, sir.
Is there any option like 83%?
No.
No?
No.
Can you share the question once more?
Yeah.
I think maybe you added wrong. 1 plus 2.01. You, I think, wrote something else. You
It
can
will
maybe
be
do that part again. Yes.
3.01. 1 by 3.01. No?
What?
1 by 1 plus exponential of that, the formula you have written. See,
It is 2.01, not 0.20.
2.01.
Yeah.
1 plus.
33%
Now you
is
will
there,
get the
right?
answer.
No, now directly you can find, right? You just share the screen, Harshit.
Okay.
Question 8.
In the option, there is 37.8 or something, not 33. Even
33
I
is
got
not
that.
there.
No,
The options
37.8.
are correct. I'm sorry. The options are incorrect. The closest was A option. I think the right answer they have given is also A.
What's the correct option? A
The
itself?
closest is A. You need to check it once. I think A is only the answer they have given. Harshit, could you check?
Let's find the
Yeah.
log odds. We will confirm them.
Just give me a minute. I will check on the GPT.
We'll find the log odds too. minus 0.5 we are getting, right? Let's see. Harshit, you copy the question and put it on the chat box.
I already put it.
Okay, fine.
How can we figure out the odds from this data?
No, we already have the probability, right?
Yes.
33%. So using this probability, we can find the odds. For odds, we only need the probability.
Okay, I understood.
0.59. Is it odds or log odds?
Log odds.
Log odds, right? I will find the log odds. Screen is visible, right? 0.49.
No.
Yes. Now it is. The calculator.
Yeah, that's it. No, we are getting a different answer. Answer is 0.5, right?
Yes, minus 0.
We got minus 0.7. No, we'll see. I don't know whether this is the right method or not, because in the question it is also mentioned to use y is equal to yes and 0 is equal to no. If it's okay if I do it later and let you know.
Yeah, sure, works.
Rishabh, here is the solution that I get.
What, Harshit?
I got the solution of the detailed solution of it.
You just
Yeah.
there from where you got. No, I think it's better we discuss. No, if you have, you just say.
Okay. I'll stop sharing.
You can present the solution also if that's okay.
What?
You got the solution, no?
Yeah.
So you can present the screen and share.
Okay.
Yeah, this is what I'm talking about. This is how I'm doing, and I'm getting the answers.
No, once
It is
again,
like
Harshit.
2-line questions.
No, the answer is what's the log odds and the other one? Harshit,
the
present your
probability.
screen.
I presented. Is it visible?
Yeah. Go down. Yeah, till 0.7 we got, right? Wait, 0.3319. Yeah, we got the same. We got 0.3322. Logistic. Probability, yeah. Let's try carefully. Yeah, but none of the option matched 33.2. Go down. What's the conclusion? Log odds minus 0.7. Our answer and for the answer ChatGPT gave are similar or same exactly. But let's see. I don't know whether this is the right approach or not.
But wasn't our log at 2.01 something and here it is 0.7?
Our log odds was log odds, right? What is it? R was 0 - 0.7133 log odds.
Okay, okay. My bad.
Our odds was 0.49.
Okay.
No, answers are exactly right, but sometimes this ChatGPT also gives wrong answers.
Just so, like every questions that they have given us of logistic regression,
Yeah.
for every single question, Chat GPT, DeepSeek, Gemini solves like this only. For every single question.
What?
For every single question, Chat GPT, DeepSeek, Gemini solve this way only. I've checked 100 times because I was not getting the solutions, like the key they have provided us. So like okay, so midterm questions have been given. No, so next time when you solve midterm, you can just check this formula also, which is a two-line formula. I feel like that because the thing that you explained today was lengthy for me. What I have learned, because in that you only need to remember the intercept and slope, and if error is given, that way you
Yeah.
can find the log odds, and the probability you can directly find by 1 divided by 1 plus e to the power minus log odds. So see, here it is already minus 0.7. No, so when you put it in the e to the power minus 0.7, so minus gets cancelled and you get the answers directly. Like you don't have to find first linear regression, then exponential, then probability, and then log odds. You can directly find log odds and probability. It will save you much time. In statistics, 25 questions are there.
Yeah.
No, if you guys find some approach or some equation as easy, you guys go on with that, no issues. But if the equation that I mentioned was the first equation you are seeing, better use that itself. Like, don't get confused. Like we only have like 3 4 days, right? So better use that itself. Fine. No, we all. I mean, we have like a faculty session on Thursday or something, right? For the sample question paper. We'll see there too. Should we proceed with midterm questions or should we end?
No. We will conclude like it is already 4.5 hours. 5 hours.
Great.
Yeah.
Then we'll come
We
to
will
that.
notify you guys when we are doing module 3 and 4 and the midterms. Guys, how was the today's session like? The concept energy.
It was very helpful.
Yeah, it was good. But like, we are not in
We
your
have
pod.
session problems.
What?
It's just that we don't have session problems. The thing is, the answers we get don't match the answers that they have given. So we feel like whatever we're doing is wrong. That's the only
Yeah.
issue I feel like that we have.
Exactly,
जो भी
and
कर
my
रहा है,
fear is
वो
that they
match ही
will
नहीं
prove
होता
us
है.
wrong. Like I can like I think in the like microeconomics also that we were thinking that they have given us the wrong questions, but they proved right like how the questions were coming. I'm like I have the same fear that in this also they'll prove us wrong कि भाई हमारे question सही है तुम गलत कर रहे हो.
Yeah.
And that too one day
हाँ, और
before
हमको पता
exams.
Yeah, like maybe we should ask them to give the solutions of the questions also, and not just the correct answer. Like how they are
They'll,
solving,
Yeah,
they
correct.
should give that also.
they'll mail you that please wait for live session because
Like
the live
we all
session is basically for that only, no?
like we all have to request for this, like the detailed solution of the sample paper.
And just a suggestion, maybe tomorrow we can start a bit early and cover all three components.
Like
Yeah,
tomorrow is Monday, so
hopefully,
some of them have a college.
like how you want, like the next 2 3 sessions, how you guys want. Like I know this is a bit too hectic, 4.5 hours. No, the best thing for us is that if we conduct a 2 hours class or a 2 hour session, in the end there will be like 2 3 of us.
Yeah.
Others all would have left, but here we have much good participation. No,
Personally, I have no issue for sitting like for long hours or something. But if, like for me, I have off in my college, like I have holidays, so I don't have an issue if you start early also. But
Okay.
see how it's feasible for everybody else. But it's okay if we even start early or
no,
spend
today
more
we'll
than 4
conclude
hours.
here. No, you
Yeah, sure.
guys mentioned like should we conduct module 3 a separate session and module 4 a separate session, or should we
Yeah, I
combine
think
both?
that will be better, no? For our
Hmm.
attention span also. Module 3 you do, then do questions of those. And maybe that's what you should do. Like find out all the questions from module 3 from the midterm 2 and sample paper and do it together. And then module 4 also you do like that. And then since module 1 and module 2 is left, you can do that maybe with module 4 ke saath if you have time.
Okay,
I'm
fine.
not saying you do it in different days. If possible, do it in the same day itself. Do maybe from like 3 to 5 one session and then from 7 to 9 another session in the same day itself. वो भी चलेगा 2 घंटे का.
No,
But
we
एक
are
साथ
okay with
4
any
घंटा.
timings. We are actually okay with anything. But the thing is that like we need more people who accept the same.
Just do one thing, no? In your pod lead ka group, ask them what they think should be happening and whatever you all get more vote for, go with that.
Cool.
Okay.
We'll do that.
And Rishabh, I'm not included in your pod group, so how will I be notified about the next meeting?
You are not in any pod.
No, I am in my pod group, but I'm not in yours, so
Uh,
maybe I
can
can get
Like
a message.
your pod leader is not sending or updating with the messages.
Like I got this one, but I think I skipped the
No,
ones that
you
are
just
not
put your
present in
number
the.
on chat box. Harshit, you can update, right?
I just contact me on my WhatsApp. I will share the links
Yeah, yeah.
to you.
Okay.
I
In
think
which
we can conclude here. Yes, Harshit.
RT your pod number?
2.
Second. Okay. So
Okay,
we
then
will
we'll conclude here.
yeah we are concluding, and we will notify about the next
Yeah.
session.
Most
By
probably tomorrow we'll be having module 3 with midterm and few sample questions. And I think like by Wednesday we should complete all courses and midterm. Let's see.
Okay.
Okay, guys. Thank you. Thank you so much.
It's